Hello, my name is Nicholas Cornell and I am with Team 2398. Today I'm going to be walking you through our easyC code. I'll explain what each of these things do. I assume that you will have at least a general understanding of what's going on here. I'm using easyC, that is my preferred programming for the specific cortex that Vex uses. Vex Robotics system. Okay, let's get started. So, here's everything that is happening with our robot. We have a pneumatics output on our digital one. All of these motors are configured correctly. I need to put in the description of these. I did this with a previous robot. I would say positive is up, or something like that, or this is the lift motor, so I don't know if this is correct, but say this would be positive is forward, that kind of thing. But since I haven't figured that out yet, I'm going to wait until that happens to put these in the description in the content. And if you're really interested in this stuff, you can pause it now, take a look at it, but it's not that interesting. Let's move on. Okay, for the globals, you'll notice some weird things in here. There's an unsigned character, which is, ones or zeros, and left, right, and mid. LCD, left, right, and mid. And then there's also LCD screen, which is an integer, and an integer for the program, integer for the LCD screen minimum, and an integer for the LCD screen maximum. And an integer for something that I use called UART select. I program that in specifically for choosing which UART I'm using for the LCD screen. Okay, let's move on to initialize. After begin, it goes to initialize, to either autonomous or operator control, and then it ends. So, in initialize, I start out. Do I have any local variables? No, I do not. Okay, I start out by playing a tone to signify that initialize has begun, that we have entered initialize. This is pretty helpful for troubleshooting things, especially during competition. We've had a case before where an indicator was a lot of help, because if they have a field error and you don't move, they don't know that it's their field doing that. They could blame it on your robot not working correctly, or your battery's plugged in, or is your backup battery plugged in, did your code hang up, that kind of thing. Okay, so after that we specify which UART I want. I could honestly do that in the main globals, but nah, this does just fine. It's just a user code here. And then we initialize the LCD, we turn on the LCD backlight, and then we start the button launcher on the specific port of UART select, which is just 1. Then we have this little subroutine here, and I'm going to open that up and show you what it's all about. So what happens is, as soon as this subroutine starts, I think there's a couple of local variables. We have main battery, backup battery, and timer logic. This is a subroutine called battery check. So what happens immediately, we start a timer, and that begins the timer, and it counts in milliseconds. Then we get the main battery, and it retrieves it to this variable main battery, and then we retrieve the voltage of the backup battery and put it to a variable called backup battery. Then we display the main battery on the LCD with the correct integer for main battery, and then for the second line of the LCD we display the backup battery voltage. Now, this little guy right here, I had a little bit of trouble with this while loop here, and if you read the comment over here, this loop waits until any of the buttons are pressed or 8 seconds has passed to continue. So what I'm saying is, while these are not pressed, while any of the buttons on the LCD screen are not pressed, these just say the same thing here. Well, it's true, but this one right here, while timer logic is less than or equal to 8,000. And that will be true if it is less than 8,000. If it becomes false, it will kick it out of the loop. So, and then I just get the timer values, all just loops around, keeps getting the timer values, gets the LCD button values. And this is just to stop and wait either 8 seconds or wait until somebody presses the button is pressed, and continues. And then it stops the timer and waits a few seconds, because immediately after this, if I don't have this there, I run into problems with immediately coming out of this and then selecting one of these LCD things. And I'm going to explain this to you. So while we're in initialization period, while this is enabled, we get the LCD button launcher, we check to see if the buttons are being pressed, and it scrolls to either the left, and then it sets the screen to the minimum, and if the LCD screen is equal to the screen maximum, we wait a few seconds. Oh wait, yeah, okay. And if that's not the case, then we just minus if the LCD right is equal to 1, and this just handles if LCD screen is equal to screen max, then we set the LCD screen equal to screen minimum. So we just loop back around basically, and then we add 1 to the screen. Okay, let's see here. Okay, if LCD screen is equal to 1, so if program 1 is being displayed on our LCD screen, so I have it set here to say blue peg autonomous, and program does not equal 1, meaning you haven't selected a program yet, and then it runs through here and checks if you have pressed the middle button, and if you have, autonomous has been selected. So you select the autonomous and the program is set to 1, and then if the LCD screen is equal to 1 and program has been selected, then program is equal to 1, program 1, it displays that on the screen, and this is in brackets to signify that you have picked the program. The same thing for 2, 3, down here, and 4. Let's see here, blue post autonomous. I have all 4 this is zones for this here, or starting tiles, I should say. Blue peg, blue post, red peg, and red post. Okay. And program is equal to 1, meaning you've selected the program. Program is equal to 2, meaning you have selected the second program. Program is equal to 3, meaning you have selected the third program, and so on and so forth. And you can add as many of these as you want, as long as you go back to your globals and change the maximum to however many programs you'll have. Say you want, like, I don't know, 6 different programs being able to be able to select 6 different programs, then you would set this to 6, but I only need 4. Okay, now we go back to initialize. That all handles that, and come down here, stop the button watcher, and then as soon as it goes into autonomous, I think it's a global that was in the I think it was a global. So your program is just set to whatever you select. And then when you kick over to autonomous, we turn off the LCD backlight, and then we run whatever program we have selected. And this is just a shell right now. I have comments over here: put your first program, second program, third program, fourth program, and I have it marked blue peg, blue post, red peg, red post. That kind of simple thing. And it runs that for all of autonomous, then it ends. Then, in operator control, there's nothing too fancy here. Another tone to signify that we have entered the driver function. And then here's all of our controls for the robot, organized very nicely. 1, 2, 3. This has 4, 5, 6, 7, 8, 9, 10, and then I have the pneumatic actuator being controlled down here. And that's just about all I have for my code right now. I'll let you know about any significant changes that I make. I plan to add a PID control that I've had in a previous robot. It basically, if you played with PID at all, you know that. Here's PID. I'll just slap one down for you. So you can define it, start it, update it, or you say you're on target, and then stop. But anyway, PID is kind of weird compared to something like smart motor control. Because, that's not what I need. Is it smart driving? Smart motors drive, yeah. If you're using it to drive, then PID is kind of weird, because PID works on an absolute value system, meaning that if you start, let's say at 0, which is usually the case, your robot starts up and it says that place where it's at right now is 0, and you move 300 ticks just one direction, and let's say you want to get back to where you started. You wouldn't say negative 300. You wouldn't tell it to go back negative 300. You would say go back to 0. And that is kind of how PID works. Now, I will let me get rid of this. I will make a PID control behave a little bit like smart motor, because that's what smart motor does. If you want to, or if you start somewhere, it doesn't really care where you start. If you say move back or move forward 300 ticks, then it will move forward 300 ticks. But if you want to get back to the starting position, then you'd say negative 300, and that's not an absolute value. That's just a relative value from where you are right now. But the thing about that is, PID is a little bit more useful because it uses these calculus type equations. Well, it is calculus. I've been working through it with my girlfriend. Calculus stuff. It talks about. Well, it basically handles errors, and you can. Here, let me put this down and see if I can get an example here. Okay, you can update set points. Define PID. Here we go. So you define which motor is being controlled by this PID function. Then you specify the proportional value, the integral value, and the derivative, and then the tolerance, which is right now the 36 encoder clicks, and that's just basically what your error tolerance is. Like if you go over a little bit over 36 clicks, it will come back to a point where it is happy with where it is. Get out of here. And that's all I have to say for that now. I should say that I am going to program PID, a user function, to make PID behave a little bit like smart motor drive. And I've had that before, and it worked fine, and it worked. There were a few bugs that I had to work out, of course, as was all programming, but I will get to that in the near future and let you know how it goes.